Welcome you all to the new session of computer graphics. Today we will be learning a new display device. It is flat panel displays. Let us look into the various features of flat panel displays. When compared to CRT monitors, flat panel displays have very thin display screens. Second point is that we know that CRT monitors were having huge weights, but flat panel displays are very lightweight. They are easy to carry and are portable. Third feature is that flat panel displays consume very little electricity during their operation, so their power consumption is very little. Fourth point is that since they are lightweight and having very little volume, they can easily be hanged on wall. So it is very convenient to use flat panel displays as a display device. Because of these four advantages compared to all other display devices, flat panel displays are considered better. Now there are two types of flat panel displays. One is emissive flat panel display and the second one is non-emissive flat panel displays. Let us look into the difference between these two types of flat panels. First one, emissive flat panels. Emissive flat panels are devices which convert electric energy into light energy, whereas non-emissive flat panel devices are the devices which convert light energy to graphics pattern. I repeat once again, emissive displays are the devices which convert electric energy to light energy, but non-emissive displays are devices which convert light energy to graphics patterns. Now we will be studying three different types of emissive displays. The first one is plasma panel. Second one is thin film electroluminescent display. And the third one is LED, that is light emitting diodes. All these three kinds of display devices come under emissive displays, and under non-emissive display category, we have only one type of display device, which is LCD. And the full form of LCD is liquid crystal display. Now, in detail, we have to study all these four display devices. Let us see what is the difference between these four types of display devices, out of which the first three belong to emissive category and the last one, LCD, belongs to non-emissive category. First we will be learning about plasma panel. In plasma panel, we will be using two glass plates. I am talking about the display screen. So behind the screen, we are having two glass plates. In the first glass plate, we are having wired conducting ribbons. So these vertical lines indicate wired conducting ribbon. So this glass plate is wired using conducting ribbon. What is a conducting ribbon or a conducting wire? A wire which can conduct electricity. Clear? So there are two glass plates. One glass plate is wired using vertical conducting wires or vertical conducting ribbon, whereas the second glass plate is wired using horizontal conducting ribbon. So both these glass plates are wired using conducting ribbon. The difference is that the first one is wired using a vertical conducting ribbon, whereas the second one is wired using a horizontal conducting ribbon. Now between these two glass plates, a thin layer of separation is there. That means these two glass plates are placed very close to each other. These two glass plates are placed very close to each other such that a small layer of separation is there between these two glass plates, and the region between the two glass plates is filled using neon gas. What did I say? There is only a thin layer of air separation between these two glass plates, and the region between the two glass plates is filled using neon gas bubbles. These gas bubbles are known as bulbs. The neon gas bubbles are known as bulbs. Now what happens when electricity is passed through the circuit? When electricity is passed through the circuit, the vertical conducting ribbon and the horizontal conducting ribbon come into contact. What did I say? The vertical conducting ribbons and the horizontal conducting ribbons come into contact with each other, and the point at which these two vertical and horizontal conducting ribbons meet, the point at which these two ribbons meet is called the point of intersection. Clear? The point at which these two conducting ribbons meet is called point of intersection. Clear? So there will be many points of intersections in these two glass plates since they are placed very close to each other. So what happens when electricity is passed through the circuit? When electricity passes through the circuit, the electric current passes through these conducting ribbons, and through the conducting ribbons the electricity reaches the point of intersection. At every point of intersection, in each of these points of intersection, electric current passes its energy to neon gas. From electric current, energy is passed to neon gas bubbles or neon gas bulbs. At that time, due to this electric power or energy, the neon gas bulbs break. All gas bubbles break and energy is released in the form of light. This released energy is known as glowing plasma. What is it? The released energy is in the form of light, and that light is called glowing plasma. Clear? This is how the plasma panel works. Now comes the second display device, thin film electroluminescent display. Now let me explain the working of this display device. As I said earlier, in this method also we are using two glass plates. One glass plate is wired using vertical conducting ribbons, and the other glass plate is wired using horizontal conducting ribbon. These two glass plates are very close to each other. Only a thin layer of air separation is there between these two glass plates. Very thin space between these two glass plates. And the region between the two glass plates is filled using phosphor. In the earlier method, I said the region between the two glass plates was filled using neon gas. But in the second method, I am saying the region between the two glass plates is filled using phosphor. And this phosphor is doped with manganese. What is the meaning of doped? Doped means adding impurity. So phosphor is impured with manganese. Clear? And the region between the two glass plates is filled with phosphor, and this phosphor is doped with manganese. Now what happens when the electric circuit is switched on, electricity passes through every point of intersection, which was explained earlier. Since the two glass plates are placed very close to each other and the electricity passes through these conducting ribbons, at every point of intersection, electric current attains its energy, and from the electricity, the energy is transferred to phosphor atoms. From the phosphor atoms, the energy is absorbed by manganese atoms. From every phosphor atoms, electricity gets absorbed by manganese atoms. And these manganese atoms release the energy in the form of light. So this is how displays is obtained in thin film electroluminescent display. Now comes the third display device, light emitting diode, which is known by the name LED. To explain the concept, let us consider the screen. Let this be the screen, the computer screen, which is divided into number of rows and columns. Clear? Now, in LED displays, every cell is represented by one LED bulb. That means, if this is the entire screen and it is divided into number of rows and columns, we will be having many cells in the screen, and every cell is connected using a LED bulb, so that if I want to draw a circle, if I wish to draw a circle, what should be done? Which all pixels do I have to select? I have to select this pixel, then I have to select this pixel, then this pixel is to be selected, this one is to be selected, this one is to be selected, and this one is to be selected. When all these pixels are highlighted, we will get a picture of a circle. Okay, this is how circle is drawn on the screen. So we know to draw a picture on the screen, we must highlight some pixels on the computer screen. So whichever pixel is to be highlighted, corresponding LED bulb will have to glow. So LED bulb, every LED bulb has two options. LED can be in the on state or LED bulb can be in the off state. If a pixel is to be highlighted, then corresponding LED will be in the on state. That means LED in that pixel will glow. And in all those pixels where nothing is to be displayed, LED in that pixel will be in the off state. So simply the technique is simple. If a pixel is to be highlighted, LED in that pixel will glow, it will be in the on state, and if a pixel is not to be highlighted, LED in that pixel will be in the off state, it will not glow. So in this way, every individual cell is connected to one separate LED. So number of LEDs will be equal to number of pixels on the screen. This is how displays are obtained in LED screens. Now we have already covered the three display devices under emissive display category. Emissive displays had plasma panels, thin film electroluminescent and LED displays. These three devices have been covered. Now comes the non-emissive display category, where devices convert light to graphics pattern, and under this category we have only one device, which is LCD, and the full form of LCD is liquid crystal display. Let us now see how an LCD screen works. In LCD screen, we are having 6 layers. 6 layers are there in the LCD screen. What is the first layer? First layer is vertical polarizer. After that, the layer comes vertical grid wires. Then comes liquid crystal layer. Fourth layer is horizontal grid wires, then horizontal polarizer, and finally the reflector. These 6 layers combine together to give the display in liquid crystal displays. Now let us see how these 6 layers work together to give a fantastic display onto the screen. See, as represented here, Initially, an arrow comes in this fashion, like this. This is how a ray of light comes to the scene. Clear? A ray of light comes in this fashion and enters into vertical polarizer. Now the purpose of vertical polarizer is to rotate the incoming beam to 90 degree vertically. What did I say? An incoming ray of light is coming to the screen. When it is entered into vertical polarizer, this polarizer will rotate the incoming beam to 90 degrees in a vertical direction. That means if the ray of light is coming in this fashion, when it hits the vertical polarizer, this ray of light will undergo a 90 degree rotation and it will attain this position. So a ray of light hits the vertical polarizer, it attains a 90 degree rotation in a vertical direction and the direction of ray is now in this fashion. Now the vertically rotated ray passes through the next layer, vertical grid wires. These are conducting wires which conducts light and graphics patterns. See, the vertically rotated ray of light passes through these grid wires. Vertical ray passes through these vertical grid wires and reaches the next layer, which is liquid crystal layer. Liquid crystal layer consists of crystalline molecules. Liquid crystal layer consists of crystalline molecules. These crystalline molecules are arranged in a spiral fashion. These crystalline molecules are arranged in a spiral fashion. So they are liquid crystalline molecules which are arranged in spiral fashion. What happens? Initially the ray of light came, it underwent a 90 degree rotation and became a vertical ray. After passing through vertical grid wires, when the vertical rays reaches liquid crystal layer, the vertical ray undergoes twist. The ray is twisted and it is again rotated horizontally 90 degrees angle. Clear? So initially this was the ray. First it hits the vertical polarizer and rotated to 90 degrees vertically, passes through vertical grid wires, reaches liquid crystal layer. In liquid crystal layer again it is rotated, twisted and rotated to 90 degrees horizontally. So now the wave is in this fashion. Clear? Now the twisted rotated wave from liquid crystal layer reaches horizontal grid wires. That means now the wave is in this fashion. Now these waves will pass through horizontal grid wires. Every horizontal grid wires, the waves will pass through all these grid wires and will finally reach the horizontal polarizer. When the horizontal waves reach horizontal polarizer, again the ray of light is twisted horizontally and again it attains the shape of this ray. Clear? It was in this fashion, and after reaching the horizontal polarizer, again the ray of light is twisted in this fashion. It is rotated to 90 degrees. Now after exiting from horizontal polarizer, it hits the reflector. So it hits like this. Once it hits the reflector, the wave is just reversed. Now the reversed wave again comes and hits horizontal polarizer and it attains a 90 degree rotation in horizontal direction, passes through the horizontal grid wires, reaches liquid crystalline layer where it attains a 90 degree rotation, and in the liquid crystal layer, after attaining a 90 degree rotation in the vertical direction, it reaches the vertical grid wires, passes through all vertical grid wires and finally reaches the vertical polarizer. Again, hitting on the vertical polarizer, it attains a 90-degree rotation in the vertical direction and it moves away from the screen. So here a ray of light first passes through all the 6 layers and hits the reflector, and once it hits the reflector, the ray is again reflected back and moves back through all these 6 layers and comes out. Only then the light is converted into graphics pattern. This is how liquid crystal layer works. Now there are 2 types of LCDs. One is monochrome LCD and another one is color LCD. Monochrome LCD is capable of displaying only black and white displays, but color LCD is capable of displaying color scenes, color displays. Clear? So this is the only difference between 2 types of LCD, and other than these 2 divisions, we are having 2 important categorization of LCD. One is active matrix LCD and another one is passive matrix LCD. So this division is based on color. This gives a color display and this gives a black and white display. So another kind of classification of LCD is active matrix LCD and passive matrix LCD. Let us see the difference between active matrix and passive matrix. In active matrix LCD, we use an electric circuit. An electric circuit for each row. Clear? We use an electric circuit for each row, and at the same time we also use separate electric circuits for each column. So how many electric circuits do we have? If in the screen we are having m rows and n columns, if in the screen we are having m rows and n columns, then one for each row and one for each column, then m plus n, total m plus n electric circuits have to be used in active matrix LCD. For one electric circuit for all the each of the rows and one electric circuit for each of the columns. So there are total m electric circuits to control the rows and n electric circuits to control the columns. Clear? Okay, now turning back to the figure once again. Suppose this is our screen and we are having separate electric circuits to control the rows and separate electric circuits to control the column. Now what happens? Since one circuit controls the entire row, if this electric circuit, if a particular electric circuit undergoes some malfunction or it is not working properly, it is having some defect in it, if the electric circuit is has stopped working, what happens? The row which that electric circuit is controlling will stop function. So if some electric circuit stops working, then the entire row which that circuit is controlling will stop its display function and a black line will appear on the screen. You might have noticed that in many TV screens or computer screens or in mobile screens, you might have seen horizontal lines or vertical lines on your screen. This is nothing but the due to the failure of a particular electric circuit. If a electric circuit fails which controls the entire column, if this electric circuit fails which controls the entire column, then the whole column will lose its display functionality and a black line will appear in this fashion. If any electric circuit is failed which controls the entire row, then after its failure the entire row will display in black color. Nothing will be displayed in that row. This clearly indicates that the electric circuit which controlled this particular row has underwent some problem. Clear? And the second category of LCD is passive matrix LCD. In passive matrix LCD, the problem of electric circuit failure can be solved using a transistor. Instead of using one circuit for entire row and one circuit for entire column, we are using one transistor for each cell. So how many transistors do we have to use? Depends on the number of cells on the screen. So total number of transistors will be equal to total number of cells on the screen. So we are using separate transistors for each cell on the screen. So one transistor is capable of controlling the display of single cell. So if any transistor has any defect in its functionality, what happens? Only that particular cell stops working. Clear? If any particular transistor undergoes some malfunctioning, or it goes the functionality of a transistor underwent some failure, or it stops working, then only that particular cell which this transistor has controlled will stop its display functionality. So only single pixel will be affected. Now what happens if more than one transistors fail, if nearby transistors also fail, if all these transistors, each transistors controlling the individual pixels fail, what will happen? A circular pattern will appear on your computer screen in a black format. If all these pixels, if all these transistors fail at the same time, what happens? It will appear as black dot on the screen. So if electric circuit fails in active matrix LCD, you will get black line displays, either horizontal line or vertical black lines will appear. But in passive matrix LCD, if transistors fail, then whichever transistor has stopped working, corresponding pixels will be displayed in black color. If all nearby transistors fail, then all those portions will be displayed in black color. So we will get a circular black pattern in our computer or monitor screen. This is how LCD screens work. Thank you.